In this video, we're going to look at graphing linear equations, both finding the equation and creating the graph given the equation. And we'll look at an application with linear equations. All right, so given a graph, what we need to do is to get to slope-intercept form. So as a reminder, that's our y equals mx plus b. So we need to find our slope and intercept, where m is coming from the change in y over the change in x. So we want to look at how y changes, which is a matter of how we move up or down. And then change in x is how we move, I want to get the direction, right and left. There we go. And then b is coming from our y-intercept. So it's coming from the coordinate 0, and then b is our y-coordinate. All right, so starting with the y-intercept tends to be easiest because that'll give us a starting point for finding our slope. So looking at this graph here, I just look along the y-axis. So I have a y-intercept there at 0, 2. That tells me we have a value b equals 2. Now to get the slope, I need a second point. I just look around the line until I can see where it kind of nicely intersects at a point. I'm going to use this one right here. I don't really want to use any of these because that's going to be a fraction and I can't even tell exactly where it's landing. But here I know it's this intersection of what x equals 5, y equals 0. So what I want to do is map how do I get from 0, 2 to that second coordinate. So first I'm going to think in terms of up or down. I mean, the order doesn't matter. We could do either, but let's say up or down. What I need to do is move down 2 units. So the direction down is negative, so this will be a negative 2 for how y needs to change. And then for x, we're moving to the right, which is a positive direction, and we're going 1, 2, 3, 4, 5 units. So for my slope, what we'll have is a fraction, and the numerator will be this change in y, which is that negative 2. So that's how we moved up or down. And the denominator is positive 5 for how we moved left or right. And then I'm just going to simplify that, so that's a negative 2/5. With negative numbers, or specifically negative fractions, you can write them 3 different ways. Negative 2 over 5 is the same thing as negative 2 over 5 is the same thing as 2 over negative 5. So whichever of those 3 ways you want to write it, it's all the same thing. So our equation, I'll have y equals slope, so negative 2/5. Slope needs to be multiplied by our variable x, and then we'll have plus b, which is a positive 2. And there's our equation. All right, our next one here, I'm going to look for that y-intercept, which is down here at 0, negative 3. For slope, I just need a second coordinate, which we have one right there. So let's see, I'll make note that we found b is negative 3. For slope, I'm going to need to move up 3 units, so up is positive, so that'll be a positive 3. And then we need to move left 2 units, which is negative direction, and 2 units. So for slope, in the numerator, we'll have our change in y, which is that positive 3, and in the denominator, change in x, which is that negative 2. So that slope is a negative 3/2. So we'll have y equals at negative 3/2 times x, and then plus b, which is a negative 3, so we'll have a minus 3 there. Don't forget x. That's a common mistake with these, to get focused on the slope and the intercept, but we have to have our variable. You should always have y in there and always have x. All right, our next one here. So our y-intercept is at the origin. So what this tells us is that b is going to be equal to 0. And then looking for a second coordinate, Let me go ahead, and there's one here at 1, 2. I'm just going to go a little bit further to show what happens if we don't choose the one that's closest to it. And I'll show you how it's exactly the same, because the slope stays the same across a linear equation. So to get there, we need to go up 4 units. And we need to go to the right 2 units. So those are both positive directions. So for slope, we'll have our fraction, change in y in the numerator, change in x in the denominator. So that's 4 divided by 2, which is 2. Now, if we had gone to this coordinate right here, we would have gone up 2 over 1. So we would have had 2 over 1, which would get us to the same slope. So you don't have to choose the point that's closest. That second point can be anywhere on the line. It'll give you the same solution. Same thing, we could have gone in this direction and down 4, left 2. So that would have just made -4 over -2, which is still a positive 2. So there's a lot of freedom with this in terms of how to move across the line. So this will be y equals our slope times x, and then plus b, but b is 0, so we don't have anything else to add on there. It's just y equals 2x. All right, for this line here, we have a coordinate at 0, 4. So that tells me that b is going to be equal to 4. And then to get to a second point, let's see, I'm going to look for, here's another coordinate. So we need to go up 3, so that's positive. And to the right, 1, 2, 3, 4, 5 units, which is positive as well. So we'll have our slope. In the numerator, we'll have change in y. In the denominator, change in x. So this is going to be a positive 3/5. So we'll have y equals 3/5 times our variable x plus b, which is positive 4. So given a line that's graphed, find that y-intercept, then use a second coordinate to map out the slope, and then you can put those two pieces together to make the equation of the line. All right, so now what if we're given the equation of the line and want to create the graph? So it's kind of the same process. I usually start with our y-intercept. And when we look at our equation, what I think of is if you find x, what's multiplying with it will be your slope, and what's adding on the outside will be your y-intercept. So for this one, we have a y-intercept of -2, and what that does is that gives me a coordinate that I can graph. So we have a point, all we need is a second point, and this is where we use the slope. So we have the slope of -1/4. For this, I like to move the negative either to the numerator or denominator. It doesn't matter which one, so I'm going to go -1/4. And what this does is it tells me how to move, how to get to that second point. So that numerator, again, tells me up, down. So because that's negative, that means we're moving down 1 unit. Then the denominator tells us how we move left or right. So since it's positive, that'll mean we'll go to the right 4 units. So let's follow how we do this. So from our y-intercept, I'm going to go down 1 and then to the right 4. And with that, if you lay down a ruler on your paper going through those 2 points, that'll do it. Something I like to do is just grab a few more points by just following that same path, down 1, right 4. And then you can move in the opposite direction and you would just switch both of them. So I'd go up 1, left 4. So if you switch both, that'll work as well. So with that, I'm going to draw my line through those points, put arrows on the end, and there's our graph. With this next one here, same idea. So with this one, we have a y-intercept of -5 and a slope of +4, which I'm going to write as 4/1. So I can see we're going to go up 4 and right 1. So I'll graph my point at -5, and then I'll just follow that path of going up 4, right 1. 4, right 1, and then I could grab a few more points if I want to, and I could go in the opposite direction even, so left 1, down 4, and then I'm just going to connect those dots. And then draw arrows on either side to show that it continues forever. All right, so that's how we can draw a graph. So get that intercept and then use the slope to map out a second point. Okay, let's go to a word problem. So here we're given a linear equation, this 2.5x plus 397. So something we can note is that 2.7 is going to be, or sorry, the 2.5 is our slope, and our y-intercept is that 397. This is mapping the population of Lansing, so that population is y, and then it's in thousands, so that'll be good to know for our units. And then for X years after 1980. So for X, it's in years post 1980. Okay, so slope and interpret. So our slope is that 2.5. And what slope tells us is the change in y for each change in x. It's kind of a rundown of it. So how I think of it, and I even write a little note to myself of how to interpret it, that if x changes by 1, specifically if it increases by 1, the slope is a change in y. Now if slope is positive, then y is increasing. If slope is negative, y is decreasing. So if I wrote down this idea of x increasing by 1, well, x is represented by years, so this is going to be the idea of if the year increased by 1. Then the slope, which is describing what changes in y, which is our population. So population is going to, and since 2.5 is positive, it's going to increase by that amount of slope, which is 2.5. And then we just need to be aware that population's units are in thousands. So this note here, you do not need to write this. It just helps me kind of organize my sentence, moving from all of this mathematical notation and how do I relate it in words. So what this is telling me is each increase in year by 1, the population will increase by 2.5 thousand. So I'm going to write it as the population increases by 2.5 thousand, which is the same as 2,500 each year. And that interprets our slope. All right, the intercept. That's b, which is 397. So this is what happens when x is equal to 0. So if year equals 0, which year 0 is the idea of 1980, so I'm just going to make a note of that's really telling us it's 1980, then population is equal to 397,000. So this is just giving me a relationship between year and population. So in 1980, the population was 397,000. That's that one. All right, part C, in what year does the model predict that the population of Lansing was or will be 442,000? So here they're giving us a population, so they're giving us a value for y, And y is working in units of thousands, so what I want to do is actually get rid of the zeros and think of y as equal to 442. So I'm doing is plugging into the equation, so 442 equals 2.5x plus 397. Then I would subtract 397 from both sides, divide by 2.5 to get x equals 18. Now x is in years after 1980, so what I can do is to find the year, I just add on those amount of years to 1980, which brings us to 1998. So in 1998, the population was 442,000. All right, then our last one here is looking at the year 2008. So I need to change x in terms of years after 1980. So what I'm going to do is take the difference between those two values. So I'm going to see that 2008 is 28 years after 1980. So I'm using x equals 28, and I'm plugging into the equation. So y equals 2.5 times 28 plus 397. And then all of that can just go into a calculator and get 467. So in 2008, the population was 467,000. So there's our word problem with some tips on how to interpret slope and intercept, as well as plugging in values.